Here we go. Delayed choice quantum eraser.
You know intuitively that your actions today will influence your circumstances tomorrow. But imagine turning this scenario backwards, that your actions in the future may actually be influencing your circumstances today. Could it be possible that the future can influence the present? An enhanced version of the famous double-slit experiment, called the delayed choice quantum eraser, implies exactly that mind-blowing scenario that future events can influence past results. What exactly is the delayed choice quantum eraser? How can it possibly show that the future is affecting the past? That's coming up right now. In 1978, a physicist by the name of John Archibald Wheeler proposed a thought experiment called delayed choice. Wheeler's idea was to imagine light from a distant quasar, which is billions of light years from Earth, being gravitationally lensed by a closer galaxy. As a result, light from the single quasar would appear as coming from two slightly different locations because of the lensing effect of gravity from a galaxy between Earth and the quasar. Wheeler then noted that this light could be observed on Earth in two different ways. The first would be to have a detector aimed at each lensed image. Since the precise source of this light was known, it would be measured as particles of light when viewed. But if a light
It didn't seem like the source would be known exactly to be the same, so it would be close to it. So that seems a little bit confusing, but let's move on.
interferometer was placed at the junction of the two light sources, the combined light from these two images would be measured as a wave because its precise source would not be known. That's the way quantum mechanics should work. This is called the delayed choice because the observer's choice of selecting how to measure the particle is being done billions of years from the time the particle left the quasar. So presumably the light would have to be committed to either being a particle or wave billions of years before the measurement is actually made on Earth. This quasar experiment isn't practical, but modern equipment allows us to perform a similar experiment at the lab, where the decision to measure a particle or wave is done at random after the quantum system is committed.
It's really good that they're using the double slit experiment as a comparison because it gives us a good gauge of where they're going with it. But I guess when they explain the actual double choice quantum eraser, it shows the similarities and how they go beyond it.
And indeed, his thought experiment is confirmed that even if measured at random, when the path information is known, the light is a particle. When path information is erased by using an interferometer, the light is a wave. But how could this be? The light began its journey.
To me, it wasn't too clear this distinction when it's measured it becomes a wave or not. I think they should have explained this better because that wasn't clear for me from the video.
Billions of years ago, long before we decided on which experiment to perform. It would seem as if the quasar light knew whether it would be seen as a particle or wave billions of years before the experiment was even devised on Earth. Does this prove that somehow the particle's measurement of its current state has influenced its state in the past? This interpretation is where things get fuzzy. The most conventional way to interpret quantum theory is to presume that quanta, like photons, have potential wave functions, meaning it is really not a particle or wave, it's just a wave of potential, and this potential collapses into a definite state when observed. So in this view, the act of measurement gives reality to the quantum particle. So in the delayed choice experiment, this means that quantum doesn't become real until you measure it. So this experiment does not prove that the present has influenced the past because the light could have just been a wave and particle at the same time and only became real when it was measured. However, another more
I never really understood this concept much, but a wave particle is not real. Why? A particle is real, so why is a wave particle not real? That concept eludes me every time.
recent experiments set up used a more complicated method to determine this idea of the future influencing the past. it introduced something called the quantum eraser to the delayed choice experiment. So it is called the delayed choice quantum eraser, and it was designed by Kim, Kulik, Shi, and Scully in 1999. It's a complicated construction that introduced entangled pairs of photons to Wheeler's delayed choice experiment. I'm going to show you a much simpler setup that will illustrate this concept in easier to understand terms. Let's take the standard double slit setup for firing single photons. But instead of letting the photons go to a screen after it goes through the double slit, we will split the photon into two entangled photons using a barium borate crystal. Since these photons are entangled, we can measure one photon without touching the other. In addition, we'll place a lens such that regardless of whether the photon exits from the top slit or the bottom slit.
So there seems to be two divisions. One is the double slit and one is the entanglement. I don't really know how the BBO crystal separates it. I think it would be interesting, a small explanation of what's going on there. But then again, he didn't explain how it separates in the double slit, and I know that. But I don't know, it would be nice, since this is a quantum video, to just a quick explanation of BBO crystal, how it separates into two entangled photons.
The two beams will always combine at detector 1, such that we cannot know which slit the photons came from. So this lens acts as the eraser because it erases the which path or which way information of the photon. Next, we'll take several measurements on the entangled pair of the photons coming out of each slit. We place a beam splitter such that a photon has a 50% chance of being diverted downwards and 50% chance of going through the splitter. We do this for photons coming from the top slit and the bottom slit separately. When the beam is diverted downwards, the two beams from the top and the bottom slits combine such that the which path information or the which way information cannot be known. In other words, if the detector 4 detects a photon, it will not have the which way information. The combining of the two beams is the eraser. In other words, the which path information is erased at detector 4. But if the particle exits the top slit and is detected at detector 2, the which path information is known, because detector 2 can only detect photons from the top slit. Similarly, if the particle exits the bottom slit and it's detected at detector 3, the which path information is also known, because detector 3 can only detect photons from the bottom slit. The results of this experiment are pretty amazing, because here's what happens. When detector 2 senses a photon, detector 1, which senses its entangled photon, shows that it's a particle, not a wave, because we see a double-line particle pattern. The same thing happens when detector 3 senses a photon. Detector 1 shows its entangled twin as a particle. However, when detector 4 senses a photon, detector 1 senses a wave pattern, not a double-line particle pattern, because its which path information is not known. So far, nothing is surprising here, right? This tells us that when the which way information is known, that is, when the detector can ascertain.
So here's when they finally explain what the which way information is, which I haven't seen used with that wording before, but I really wish they would have explained it in the beginning of the explanation of the experiment, because they talk about this concept throughout. Oh, this detected the which way information, so you can see it, the pattern this way. This with the eraser in the bottom, detector 4 it doesn't. So I was trying to understand this concept. If you would have explained that from the beginning, it would have made the video way more intuitive. I find I had to watch it a couple of times.
Which slit the photons came from, it will always present as a particle. But when the detector cannot ascertain which slit the photon came from, that is, when the which way information is erased, the photon acts like a wave. But I'm being a little cheeky here because I left out a tiny but crucial detail that makes these results shocking. And that detail is that the path to detector 1 is much shorter than the paths to detectors 2, 3, and 4. So the photon is always detected at detector 1 before it is detected at any of the other detectors. So this is the delayed choice aspect of this experiment. An interference pattern forms on detector 1 even if the which path information pertinent to the photons that form it are only erased until much later in time at detector 4. And a double line pattern forms at detector 1 even before its which path information is ascertained at detectors 2 or 3. This shows us that somehow the photon at detector 1 knows ahead of time which detector its entangled pair will end up at in the future. So it seems to show that the future state of the photon at detectors 2, 3, and 4 affect the past state of its entangled pair at detector 1. And these results are absolutely consistent.
Something that I really didn't get about this part is it seems like one of the photons suddenly speeds up here to get a higher distance at the same time, but it might be that they are just one behind the other. So, yeah, that wasn't really clear to me because it seems like one is on top of the other, and it seems like one just sped up here. So I didn't like that representation unless they're side by side, and that's just a 3D visualization. Yeah.
Consistent and have been demonstrated in multiple experiments over and over again. How is this possible? To be perfectly honest, I don't have an answer. No one has a good answer. If you have an answer, let me know, because there's a Nobel Prize waiting for you. But not knowing the answer is not going to stop us from speculation. What is absolutely clear in these experiments is that the measurement of a particle in the present can influence the properties of that particle in the past. In other words, a decision made in the present can influence something in the past. The effect seems to precede the cause, but maybe our sense of time flowing in one direction is not something that entangled systems are constrained by. The entangled particles seem to be immune to the direction of time, or are somehow connected in time even when they're not connected in space. Maybe our causal experience is just that, an experience, but not the true nature of reality. Cause and effect seem to be temporally separated in the quantum world. But let's not extrapolate these results to their most absurd extremes. There can be no communication between the future and the past. This would violate all kinds of laws in physics, like conservation of information, conservation of energy, thermodynamic principles like entropy. But does backward causation mean that a future cause is changing something in the past? What came about in the past has already happened, when the past was the present. The past cannot be changed. The past is fixed. Maybe the past can be changed. You can't change the past. Maybe the past can be changed. You can never change the past. How can you change the past? You can't change. Maybe the past can be changed? Arvinash here. If you like our videos, please support us by subscribing. Subscribing costs you nothing. It just means that you're going to be in.
What I got mostly at the end there, it seemed like, personally, I would choose the path of there's a destiny involved, in which the particles' path, they were predestined to be one when they were entangled because of the orientation of all the other particles in the universe and how they're related to one another. So if they follow that path, they will eventually end on that. We just don't know until it happens. But the path could be potentially already predetermined. So that could be one way of explaining it, I think. But I think in physics, that destiny mentality has already been disproven as well through other experiments, or somewhat disproven. So, but that's my take on it. Hope everyone had a good experiment. Have a good one.